Welcome to another Todd's
2-Minute Tech Tip Tuesday.
Brought to you by the National RV Training Academy, the only academy that gives you the credentials to become a certified tech and/or certified inspector. All right, I want to go ahead and forewarn you, we may not be going just to 2 minutes. We're going to be going over on this particular topic. I do apologize about that, but guys, there's some information that I need to get out there. A couple weeks ago, we did a 2-Minute Tech Tip Tuesday on hot skin, and I gave one example of a hot skin, and that is, of course, whenever you have a reverse polarity situation combined with a neutral ground bonding, you can have a potential hot skin situation. We even recommended some opportunities or some things that you can do to protect yourself, namely one either being an EMS or a monitoring device. It just depends on the name you give. There was some pushback, specifically from a particular group, saying that we are dangerous in actually stating that you should use an EMS and that we are incorrect. Guys, I want to go ahead and just, stop right here and let you know this is serious, and I do apologize. There's nothing funny here, especially when we're talking about electricity. But as a school, we have some standards, and this is what we're going to go by. The two sources that we have are going to be the RVIA and the NEC, which is the National Electrical Code, by way of their book, which is the NFPA 70. So let's first start off with the situation that we have looking at the RVIA. Now, I do understand there could be some interpretation here, but let's go ahead and go over this. The first one reads this. Another example when we're talking about hot skin. Hot skin problems in RVs are typically high resistance shorts. High resistance shorts do not cause the breaker to trip or fuses to blow. These types of shorts are a result of insulation on the wires rubbing thin, so our neutral or our ground and our hot rubbing thin, causing them to actually make contact with one another. Rubbing thin where this can cause problems, but not a dead short. So we're barely touching, not a dead short. Another example would be where the white, which is the neutral wire, is cross-connected to the ground. In this case, where there's also a reverse polarity situation. So we've got a reverse polarity situation and our ground and our neutral combined. The power would bypass the circuit breakers and not be impacted by the overcurrent protection. Our breakers are only on the hot, not on the neutral. Of all the tests that are conducted, this is one that should be conducted on every RV that is being serviced in an electrical system. So guys, what was just expressed in the RVIA manual states that if we have a reverse polarity situation and our neutral and our ground are crossed together, touching one another, we can have a hot skin situation. Now we're told that, we've misinterpreted that, and guys, we're susceptible to errors. But I want to go ahead and now reference the NEC, the National Electrical Code. And guys, this is the standard. We get thrown into court. Anyone, when it comes to electricity, this is going to be the standard, not some person on the internet saying that it's wrong. So I now reference you to Article 551, Part 4, Section D. It says reverse polarity is a known cause of many incidents of people receiving electrical shocks from an RV. The chance of having reverse polarity to the RV is increased because RVers are often plugged in at locations other than the campground, namely, say, a house or something that they don't know. These sources of power, unknown to the RV consumer, can have reverse polarity. Reverse polarity incidents are also more prevalent because of customers' non-listed adapters that can be inserted backwards at the receptacle. Reverse polarity indicating devices are readily available. Not only do they tell you that reverse polarity is a condition where we can get shocked. Now, it's not the standalone condition. I want to make that clear. Reverse polarity by itself doesn't cause a hot skin situation in most cases. I'm going to leave that caveat because, guys, when it comes to electricity, there's always a possibility, okay? But when we have some other failure, we're going to have a hot skin situation. The NEC actually recommends a reverse polarity monitoring device. Now, to say that we are dangerous in letting people know or recommending an EMS, energy management system by one brand, a surge protector monitoring device by all other brands is dangerous. This is insightful to me because we are protecting people. And to say that that is dangerous, I think is dangerous itself, okay? These do monitor and they do protect you. Now, are they infallible? No. Can they be fooled? Sure. If someone goes in there and miswires, there may be occasions where if it's a bootleg neutral or bootleg ground, this is where we actually combine the ground and the neutral, we might actually fool that. But here's the thing. If the NEC says that it's okay, then this is what we're going to recommend. As a school, we're going to go with what the NEC, what the authority states, okay? If they change, we will change. Do I make mistakes? Yes. As a matter of fact, I actually misworded in the video. I said that fiberglass was a resistor, and it's actually an insulator. The question is does fiberglass conduct electricity? The answer is no. So yes, there are occasions where, we make mistakes, and we will correct them. There may be occasions where the NEC has to do updates. We see that they do updates all the time. But as a school that you can trust, this is what we're going to follow, not people on the internet. So in the 2 minutes, I'm relegated basically to one or maybe two instances. Guys, there are several occasions where we can have a hot skin situation. An errant screw or nail, even from the manufacturer or something that you put in the wall, actually goes in and makes contact, with the hot side of a cable. So in the Romex cable, that screw goes in, touches the hot side. Well, now we get what we call a localized hot skin situation where that screw is. Now, if that screw is actually in a metal frame, guess what? The whole frame is now electrified. To what amount? Well, this is where actually using a true voltmeter comes into play, okay? Because we do need to look at how many volts are there. What is dangerous, what is not? Generally accepted is that 5 volts or less is not dangerous. And this is what we teach. Anything above 5 volts, well, that's not natural. That is man-made. And if it is man-made, what may be 6 volts today can be 120 volts tomorrow. All we have to do is just wiggle that screw, go down the road, bounce around a little bit, and now we make fuller contact. And this is what we're going to teach. I understand that there are people out there that may disagree in the way that we state this, or, that there may be varying opinions, and that's totally true. But which are we going to follow? Are we going to follow the book, the National Electrical Code, or are we going to follow people on the internet saying that this is wrong, okay? They can update that, okay? And then we will change at that point. But I'm telling you, what we're going to follow is the book. So, and I will say this, just on the side, when you come to the National RV Training Academy to become a certified tech or a certified inspector, we're actually going to teach you how to do a hot skin test, okay? We will teach you the right way using a true voltmeter and actually find what type of voltage we have. We're going to have some stray voltage. Having the non-contact voltage pins out there, they're great for certain things, okay? But they have their limitations. Most of those don't even start till 50 volts or 90 volts. One of the most popular one, the Fluke pin, doesn't start till 90 volts. Guys, 89 volts will definitely pierce your skin and cause electrical shock. All right? If we know that 5 volts is generally the accepted upper range, then we would need to have a pin that can actually monitor below 5 volts. Okay? Those pins, best ones, start off at 12 volts. And again, what is 10 volts today, not natural, can be 120 volts tomorrow, okay? So when we teach hot skin here, we're going to show you how to use your voltmeter, extend out your common line to make a ground connection 50 foot, 100 foot long, and then actually touch every metal device that is on your rig and check for voltage. Guys, this is not something we're playing around with here. It is something that's serious, and this is stuff that we are going to teach you. If you want to be able to fix the majority of the problems on your rig, but let's say you want to open up a business, become a certified inspector or a certified RV technician, head over to our website at NRVTA.com, click on programs, and get started today.